研討會即將開始，提大家，參加者不可使用任何程式進行錄影。今日嘅 Live First Water Talk 臨時工程管理網上研討會正式開始。各位講者、各位來賓，大家好，歡迎大家參與今日嘅研討會。我係今日研討會嘅司儀 Phoebe。議會之前已經推出臨時工程管理參考資料，透過臨時工程嘅設計同埋認識管理控制關卡，以提升建造安全。而今日研討會嘅內容亦都非常豐富。依家我哋就即刻有請第一位講者，香港臨時工程論壇 Executive Member Mr. Ian Mowat。Now, please welcome Mr. Ian Mowat for sharing the Precasting and Platform approach. Please welcome Mr. Mowat.
Good afternoon. My name is Ian Mowat. I'm an ex-chairman of the Temporary Works Forum, and I'm going to talk about alternative methods of construction today. So that is who I am. Construction at the moment is a failed industry. Had we been making cars, for example, we would have been put out of business. We cannot continue to kill people at the rate we do and have accidents at the rate we do and expect people to take us seriously. They don't. Construction industries don't fulfill client expectations. The last site I was on was 2 times over budget and 3 years late. I mean, that is not acceptable. It is absolutely not acceptable. We kill in the region of 30-odd people a year, and we keep on working very, very hard at trying to make sites safe. We're trying to make a very unsafe industry into something that is safe, and that's not possible. Whatever happens, and however safe we make it, we are still working at height. We're still working with live electricity. We're working over roads. We're working over water. So it's time that we change the paradigm completely. So I'm going to talk today about different approaches to construction, and I hope that I'm going to get some feedback from you people, because the people who have registered here are quite young, and the future of construction is in your hands. So I'm going to give ideas out in the hope that you will come back and give me some feedback on this. So we started with MIC. MIC is not a new concept. It's quite an old concept. The containers you see was the very, very, very early MIC. Then we started making up units, and we started erecting the units on site. So we've moved a very unsafe process into the factory. However, it still has problems. We precast in the unit, we're fitting it out, we've got pre-finished, and then we move it onto site. So we have some challenges with MIC. It's very heavy. We still got working with height because somebody has to get up onto the top of the unit to release the crane shackles. So we still have working with height. We still got challenges with that. And there is an issue with lifelines and anchors on that. Generally, when I've seen people unshackling containers, they are fixed to a lifeline that is actually below their feet. The anchor point is below their feet. So if they fall off the container at height, then it's a fixed line lanyard, which probably the anchor will fail by the time they stop falling, or if it's a lower height, they hit the ground before an elasticated lanyard works. So there are challenges with MIC, but it is a major, major step forward. Of course, the other thing with MIC is it's quite expensive because we've got double slabs, we've got double walls, and whilst that's very good for sound insulation, it's not very good for cost. So the double wall system and the double slab system is excellent from a fire protection point of view, but it's not very good for a cost point of view. So the fully furnished modules, the advantages are that we transfer operations to a factory, so increase the quality. There's less time to erect, less skilled labor. So all the things that we need to achieve, it does achieve. However, it does have some disadvantages. The weight is a disadvantage, and it doesn't totally eliminate work at height. The grid size is limited to road transport, 3 meters by 6 meters. Now, Cambridge University did a study on grid sizes, and they came out with a number that a 15 by 9 meter grid suits every single building ever built anywhere in the world, which is a sweeping statement, but it does seem to fit. So a module that works within the 15 by 9 meter grid is ideal. So then we move on to the factory in the sky. Now, this was a very brave experiment. It was done in East London by Mace. A very brave experiment. It never really worked. But it was a very, very good idea, because you transferred all of the site activity to a factory activity, but the factory was actually on the site. So it was a very good idea. The photograph there that I'm showing there is an aerial view of the factory. It was lifted on the 4 corners of the building, so it was very complicated hydraulics to lift it. It was all fully automated insofar as it was all precast. There were no tower cranes on the site. The orange things were the tower cranes, a gantry crane, moving over the top of the factory, lifting precast units into place. The advantages were that it was all precast. It was a 10-day floor cycle, including the finishes and the curtain walling. So it was a completely weather-tight structure, lifted up, and it was modern methods of construction. The disadvantages are it was very, very difficult to dismantle. Very, very so. All the time they made up in the construction was lost in the dismantling. It was also expensive. It cost 8% of the total building cost. And there are very, very few subcontractors with that kind of hydraulic experience, because you had to lift the whole thing on the 4 corners of the building. So I did some work for Brighton Wood a while ago, and I was really impressed with what they were doing. They adopted a platform approach very much copied from the car industry. For example, an Audi has got exactly the same platform as a Volkswagen, exactly the same. And that's what they set out to achieve. So I'm going to show 2 videos now. The first is the module, the mock-up that they did to show that the modular approach would work.
Today we're in the Construction Platforms Research Centre in a place called Ropley. It's actually a farm, but a farm that I think is going to be a catalyst that's going to help change the future of the construction industry. Today we've been showcasing some work that we've been done researching the use of platforms in construction. The vision was, how can we take the construction of a commercial office building and break it down into a kit of parts that we could deliver onto a site and assemble, rather than construct a building in a traditional way.
So what we've got to do is take the precasting techniques and bring them to site.
What we're doing here effectively is we're trying to develop what we call the productive routine, so the processes that people can repeat time after time safely on site and efficiently, which drives productivity.
So the Transforming Construction Challenge is there to help the sector change the way it works. And this project, it's almost an ideal example of the kinds of things we want to see. We want to see a kit of parts approach coming forward, a platform approach to buildings, taking a manufacturing discipline to construction so that we are changing the processes.
The prototyping has been key in being able to prove that those ideas are practical and really work, and to build the confidence both in ourselves as a client and in the construction industry partners that we would use to build a full-scale project.
This project it takes out so much of the interface problems that have caused so much trouble in the past. It just uses intelligent techniques like not lifting up the really heavy stuff or not transporting the really heavy stuff miles and miles and then craning it into place, making a set of very standardized lightweight components that you can put together really easily with low manpower, and then pumping in the concrete at the last minute.
So our involvement in this project has been as the design development team alongside Bryden Wood and the prototype builders. This is the third platform. Platform 1 was for smaller spans. Platform 2, again, that were a larger span, and that were for residential, which got companies like Landsec who were wanting to improve how they build their offices. Offices need a larger span than what Platform 2 can offer, so naturally we called it Platform 3 and gave them larger spans.
So for us, delivering the kind of targets we wanted to see in terms of faster delivery of projects, lower cost, greater productivity so we can produce more with the same workforce, and reducing emissions and improving the whole life value of the buildings.
It's important that we don't just get time and cost savings, we need to do things better, we need to do things safer.
It reduces the amount of people or workers that have to be on site, so that means that it reduces the risk in terms of having accidents and incidents.
We've gone from the sort of laboratory into the real world, and the real world is now really, you know, we've been on site at Sumner Street and ready to start construction in the early part of 2020. So getting all of that learning and applying it straight away is fantastic. It's always hard to innovate, it always feels risky, and the team have marched through all of that and achieved a huge amount, and we really have line of sight now to executing on this first building down in Southwark, to then take it on to the next and the next and the next.
There are tremendous opportunities to improve productivity in construction. So, you know, unlike other industries which now are making incremental gains, we've got this opportunity to really leap forward in terms of productivity.
You have one of the UK's largest companies working with one of the UK's smallest companies with probably one of its most innovative design organisations that have come together to really produce something that we hope will start to change the way that buildings are designed, delivered and constructed.
That was the platform approach provided by Bryden Wood. I'd just like to show a video of the actual office building that they did build in London. So the building is called The Forge, and Bryden Wood put it together. So this is a video, a very quick video of that.
Welcome to The Forge in central London. What you see around me is one of the most significant events in the future of construction. The Forge is the world's first major commercial development, developed by Landsec, to be designed and built using a platform approach for design for manufacturing assembly. It's also the UK's first net zero carbon commercial building. Let's have a look at platforms, what they are and how they work.
A platforms approach takes the lessons learned by the manufacturing industry and applies them to construction. In traditional construction, every building is a prototype and every sector is treated as a specialism. The platform approach looks for commonality between sectors. By working out what buildings have in common, you can design a standard kit of parts that can be put together to form structure of just about any building. Standard parts fit together in standard ways, so the building is leaner and quicker to put up. What you then do with that building, the size, the shape, the style, the function, the finish, that's up to you. Standard parts are also designed and refined repeatedly, so the finished article is the best it can be. And because they are standard, they are manufactured precisely, which means we use fewer raw materials and there's no waste.
Here at The Forge, that translates into an increase in productivity of 30.5%. And we're reducing embodied carbon by 24% compared to a traditional commercial office. On a normal building site, around 30% of all materials ends up as waste. Not here.
I think another area that this project really helps is we're all focused on reducing construction impacts. We're all focused on net zero carbon buildings for the future. And having an approach here where the amount of materials is minimised and optimised, and where waste is reduced to an absolute minimum, are great steps towards achieving that goal, reducing the embodied carbon of construction. In addition to that, we've designed this building to be particularly energy efficient, using a zero carbon solution for our heating and cooling, air source heat pumps powered by electricity, taking us forward to a future where buildings will all be built to some degree in this way.
What's so exciting and transformational is this is not a theory. Look around me, this is real. This is real change happening right here, right now.
Okay, so Brighton Wood, they reduced the amount of tower cranes required, and they reduced the energy efficiency. But what is important is that they totally eliminated work at height, totally eliminated it altogether. So it was a very efficient building. So the disadvantages are we're going to have to change the way we procure construction, radically change, and we're going to have to engage with the client right in the beginning. So that is a positive plus, but getting clients to change is going to be very difficult. So we've got to engage with architects. Generally, they don't have any Hong Kong experience, and we've got to get used to a DFMA approach, including for the E&M and ABWF. So that is for buildings. So for civil engineering, we've got to embrace technology to do it. And I was a judge on a safety by design thing some years ago, and VSL put in a proposal for the OTE ducts on the Chun Mun Shet Kok tunnels. And I'd just like to show you very, very briefly what they did there. They totally eliminated working at height through technology. So they operated everything from the ground. They cast the corbels into the tunnel lining, and once the tunnel lining was erected, they lifted up the planks with remotely, swiveled them around and placed them in place. So there was nobody required for the work at height, nobody at all, and it was just using technology. So there is a future for construction, but we cannot continue the way we are doing. So I'd like to receive feedback from the listeners now, and if you've got any questions or comments on this, please email CIC, the safety seminar, at cic.hk. And thank you very much for listening.
Thank you so much. Thank you, Ian. Now, may I also invite Philip for the following presentation. Thank you, Philip.
Okay, thank you very much. My name is Philip Daines. I'm the engineering manager on the Boardwalk underneath Island Eastern Corridor project. So I'd like to thank Ian for his presentation and also thank CIC for their invitation to talk about our project. So the presentation split into 3 sections. One is an introduction to the project. 2 looks at our temporary works procedure and also draws parallels with the CIC temporary works forum guidance document that's out there in publication and being promoted, and then looking at some temporary works examples on the project itself. So Boardwalk underneath Island Eastern Corridor is a CEDD project. The project manager is Meinhardt. The contractor is the IEC Boardwalk JV, which comprises Leighton, Sino-Hydro Corporation and some key construction. It's an NEC Option C project. It started in December 2021 and is due to complete in Q2 of next year. It's part of the wider government initiative to increase the amount of promenade space along Victoria Harbour. This project's 2.2 kilometres long. We have the western and eastern boardwalks, and they're connected by the North Point Promenade. So we're refurbishing North Point Promenade and then building sections from Quarry Bay to North Point and from North Point onto Causeway Bay. There's 8 design concepts which reflect the harbour and also provide the public with different user experiences. This is just a rendering of what the boardwalk will look like on the western side, and this is one on the eastern side. In some areas, the boardwalk is underneath the existing Island Eastern Corridor. In other areas, it's in front. And it also has a number of unique features. We've got 2 lifting bridges, bascule bridges, as well as 1 swing bridge. And we also build a fishing platform adjacent to the existing Tung Choi Road pier. This is a video put together by Meinhardt, CDD and LWK during the design stage, and it just shows what the project will look like. So we start down on the Causeway Bay side. You can see the boardwalk is outside of the perimeter of the Island Eastern Corridor. Then it moves underneath. There's a number of viewing platforms all along the alignment. And then we move to the first movable bridge. The movable bridges are required to allow boat access to the inside waters, because generally the boardwalk is quite close to the sea level, so it's an obstruction to boat traffic. Then moving up, we come to the swing bridge, which is near the Providence Centre. Again, this will allow boat access along that inner waterway. More viewing platforms, and then as we approach North Point, the boardwalk comes out from underneath the Island Eastern Corridor, as there's a slip road that comes down, and then we come into Tung Choi Road Pier. And at this location, we're going to build a new fishing platform with cascade steps, which will allow users to get close to the water level, and this is quite a popular fishing area as well. So that's an overview of the project. Now moving on to temporary works. So what are temporary works? Temporary works is pretty much everything we do on a construction site. There are many forms, from tunnel supports, tower cranes, slope works, false work, demolition, permanent works that are being used as temporary work. So every engineer on any construction site is going to come across temporary work. So it's almost everything we do. We've got a whole range of different types of temporary works on the boardwalk. But unfortunately, as Ian touched on earlier, temporary works often fail. This results in injuries and fatalities, and it's really an unsustainable position. We can't keep killing our colleagues. Yeah, it's just totally unacceptable. So we have to work at ways to improve that. Ian's touched on some of those, and you'll see some of those in the presentation. But just even where we are working on a traditional style, we still can do more. So the Temporary Works Forum and CIC have published a practice on temporary works management. It's good practice, and the objective is to minimize injuries during temporary works. On the Boardwalk project, we have a design and control of temporary works procedures. That was introduced in 2022 at the start of the project, before the CIC TWF document, and our temporary works procedure is based on Leighton Contractors' temporary works procedure. A number of different contractors have temporary works procedures, but you'll see that there's a lot of commonality with the Temporary Works Forum document. Although some of the terms are different, the principles, the approach are all the same. So again, we've got different contents, but the naming may be different, the sequence they're in may be different, but they're all covering the same aspects. And we'll touch on these in coming slides. Again, as an engineering manager, and in Leighton, we have our hierarchy of controls. We try and focus on elimination and substitution. If we can eliminate temporary works, then that's the best scenario. If we can't eliminate them, then we need to try and engineer in solutions so that the works are safe. You're not relying on behavioral or other aspects. And then the controls move down through administration, behavior, and finally PPE. If you're using PPE, that is an absolute last resort. And no design should ever start on the basis someone will use PPE. So the best thing to do is eliminate the temporary works. Eliminating temporary works or engineering out solutions starts from the very start with planning. So both documents have a life cycle, and we'll go through that now. So plan temporary works and allocate risk. Temporary works can vary from a number of days to a number of years, both in the construction and in the operation. So it's important to understand the life cycle of the temporary works and also the time needed to do the design, get approvals and procure. So plan and allocate, then we do design and checking, and the very start of the design is the design brief. So a design brief, written design brief is very important because it conveys a clear set of instructions to the designer on what's required. It's important to make that as complete as possible and make it unambiguous. Saying, I need a plant platform to support a crane is a pretty vague design brief. How long do you need it for? What size crane? What are you going to be lifting? Are there any constraints? Any particular materials you like to use? So filling in a design brief is very, very important. And then another aspect is a task review. So under the procedures, a designer takes a design brief and comes up with some concept designs. And then that's reviewed jointly between the operations, the engineering team, and the designer to find what's the best balance. Because there'll often be different ways to do the same thing, and it's about finding the right balance between the options, the methods, the timing, the cost. Okay, and all temporary work's collaborative. You know, the best temporary work schemes involve design, client, operations, subcontractors, because no one person has the best idea. So involving the team will get a better solution. And it gets more buy-in, which means there'll be less change later on. Procure and construct the temporary works, and then verify permits to load, permits to remove, okay? And then managing change, because change is inevitable. Changes will happen on site. Unforeseen conditions, unforeseen ground conditions, services out of position. Change in design, which may lead to resequencing. Change in subcontractors or materials available. There's a whole range of reasons things can change, but managing that change is key. Because often changes are not checked by the designer. Sometimes there's unauthorized changes. Sometimes program constraints push how much time is allowed. And sometimes changes happen, but they're not documented, so people don't realize, and they're working on old assumptions. So under the procedures, there's a design change form. On our project, it's TW2 form. And that's to use to request and record changes and make sure that they're reviewed appropriately. So again, we have a life cycle, and every stage on the life cycle has documentation to help support that, record that, and make sure that it's a well-managed process. Okay? But a process is one thing. It needs people to operate it. So again, both documents talk about the people. They assign clear responsibilities and obligations at different stages of the procedure. Temporary Works Coordinator is a key person responsible for coordinating the planning and design during the whole life cycle, act as a bridge between and a communication link between the designer and the IC and the construction team, and to monitor the erection, use, maintenance, and dismantling of temporary works. Another key role, which we call a responsible site person, but under the CIC document, is a temporary work supervisor, is really the key person, because he's the responsible person for the safe delivery of all the temporary works execution. He's responsible, he or she is responsible for the detailed implementation of the temporary works, and obviously as part of that they're cooperating with the TWC during the design and planning stage. So the temporary work supervisor makes sure the design is built as it's planned. Again, we touched on the documentation. So again, we have a temporary works master schedule. That's the TW1 under the CIC documents. An appointment form, so everybody is appointed. They're clear on what their roles and responsibilities are, and they sign as accepting that responsibility. There's a design brief, managing design change, and a permit to load and remove. One of the differences on our procedure from the CIC document is we have a design check certificate in our procedure. The assumption from CIC in the reference material is that there will obviously be contract requirements which relate to the design checking. So on our project, we have in our particular specification a template form. We've modified that to include things that are necessary in our procedure, such as the risk categorization. At the start of our project, we did a mapping exercise to demonstrate to the client team that we have got everything you want on our piece of paper, and we've got some extra bits. But we need our form because those extra bits are very important to us in the management process. And then that was approved. So any of these documents can be and need to be modified to include the contract requirements. Every contract will have different requirements on what specified checking is required and who can check it. So the contract and the guidance documents can be linked together to perform a project-specific procedure, but a common procedure across projects. And then risk categories. Again, Our procedure, CIC Temporary Works Forum, both have a risk category because the risk category determines what qualified people are need to be involved in the design, check-in and inspection. So category A, B and C, major, medium and minor. There's guidance on what those type of categories are, and again that can be jointly arrived at during the task review workshop if there's any uncertainty. And then that risk category drives the checking and procedures. Again, regular face-to-face training, refresher training, e-learning modules, all very important in the development and implementation of temporary works management. And then one thing that we found is obviously scaffolding and access is a major part of any construction site. And managing that process through the whole temporary works procedure is very cumbersome. So we have an access scaffold and working platform procedure where we have typical designs which are already approved and can be built very easily. So common access staircases, simple access walkways along formwork, etc. So under the procedure, there's an assessment done. Is the access scaffold, is it a typical or a non-typical? If it's typical, it can follow the typical details and be constructed very easily. If it's following the non-typical, then it goes through the full temporary works control process. So that procedure then allows the complicated scaffolds to follow the temporary works procedure, but the straightforward scaffolds to follow a simplified approach. So we have nominated scaffold supervisor who oversees all the scaffolding on the project, and then there's appointment forms, assessment forms, and validation forms, the same as for temporary works. So that's an overview of our procedures. Let's have a look at some of those in practice. So going right back to the start, planning. Okay, one reason for change in temporary works is because the conditions are not as expected by the designer. There's really less need for that now because laser scanning is simple, straightforward, and commonly used across projects. So I can take a set of drawings and as-built on where the Island Eastern Corridor is meant to be, but then at the start of the project, I laser scan it, validate that, make sure all my levels are correct. There's a little bit of misalignment in some of the pile caps. I work off the as-built information from the laser scan, and that makes sure all my temporary works and my permanent works fit. So this type of thing is standard in Hong Kong now and really needs to feed into temporary works design, as is BIM modelling. Okay? BIM modelling obviously is commonly used across projects, particularly on permanent works, services and things like that. But it feeds straight into temporary works as well, because you understand, you feed in your laser scans, your point cloud, you know where all of your existing constraints are, you've put in your permanent works, and then you can really plan your temporary works to make sure there aren't any clashes, to make sure that if something's out of position on the laser scan, you're designing for that. You're not assuming it's somewhere else. So these type of tools are key to temporary works design and need to be fed early on to the temporary works designers to make sure they're designing appropriate solutions and maintained throughout the life of the project. Okay. Aerial drones, we use a lot on our projects, but not at the boardwalk. So we regularly use aerial drones to monitor progress on site. It can also be used for inspections and other aspects. But on the boardwalk, Victoria Harbour is a restricted flight zone. That doesn't prevent drones flying there, but it means there's a lot more onerous requirements, CAD approval, pre-flight plans, post-flight plans, etc. So we mainly use the aerial drones for progress photos and monitoring. But drones are something that are used generally and need to be incorporated in planning as well. Obviously, instrumentation, we're working underneath live highway, standard monitoring across Hong Kong, real-time tilt meters, vibrograph settlement monitoring. So that's all normal, but again, an important component in temporary works management, as is CCTV. So CCTV is now common across projects. It's widely used under the 4S system, and it can be an important tool for temporary works management as well. It allows people to see multiple work faces at the same time to check controls are in place and compliance. And linked with AI functions, it can also help manage things like the proximity of plant to seawalls or other exclusion zones, loading areas, etc. So again, it's taking all the tools and all the technology that's available and utilizing them to enhance the temporary works management approach. So one of the early things we did on the boardwalk was remove some of the existing dolphins. So again, the pre-works planning, the meta statement development, taking the design process, going through the designer and the ICE, and then issuing drawings for construction. We can't eliminate diving, but what we try and do is reduce it. And we can significantly reduce the amount of diving we're doing by using other methods. So this shows the diving setup. You can see multiple people involved, a lot of equipment, and diving works are inherently a high-risk operation. So by using a very cheap remote-controlled submarine, you can eliminate an expensive diving team and all of their equipment, and so you're saving money, you're lowering your costs, you're increasing safety because there's nobody in the water, and you're increasing productivity. So these type of tools, they're not exclusive. We can't eliminate divers completely, but you can take them away for a lot of routine things like silk curtain inspections, condition surveys, and validating some of our work, such as the pile removal. So you can see the video taken by the dolphin in the bottom right-hand corner here, and just some pictures. So again, we don't need any more to send people down to take a video to prove that the pile's been removed to 0.5 meter below seabed. That can be done remotely by any range of people. So using technology eliminates people working, and that's sort of what Ian was talking about as well. Adopting technologies, implementing technologies to take people out of high-risk activities. Existing pile cap repairs. So the Island Eastern Corridor has obviously been constructed for over 40 years. The Highways Department have a rolling maintenance regime. So as part of the boardwalk project, CEDD have taken some of that on board, and we had to repair a number of pile caps. We had different types of working platforms to do this. We had some where we lowered a basket onto sliding rails, which then moved along the pile cap. Others where we did traditional scaffolding for various constraints. So again, different solutions for different areas with different advantages and different disadvantages. Marine piling. Anyone who's driven along the Island Eastern Corridor in the last year has probably seen a lot of barges parked quite close to it. We've got piling outside the Island Eastern Corridor on the harbour side. We've piling inside the Island Eastern Corridor, and we've piling underneath the Island Eastern Corridor. So we've got different solutions in different areas. So we use board piling outside the Island Eastern Corridor. That meant we could have large barges with large cranes. We had flat top barges for laydown areas, and using RCD rigs and permanent casing, we were able to remove heavy platforms. So the platforms that we used are in the bottom right-hand corner. They're only for people access. So for welders welding the casing, steel fixtures guiding in the cage, and then the testing for coding testing, interface coring, those type of things. So very small platforms, light-duty piles, easy to install, easy to remove, light-duty platforms. And all the heavy works are on the barges. Inside the Island Eastern Corridor, we can't use those big crane barges. So therefore, we're looking at using piling rigs with swing leaders, where we are working on the existing seawalls and then building platforms on temporary piles into the sea. So again, from a temporary works point of view, we have to assess the seawall stability, carry out any enhancement works that are necessary, and then design the platforms. Underneath the Island Eastern Corridor, we took a different approach. Because we're working under the Island Eastern Corridor, we can't use the big cranes, we've got very limited headroom, but we have the opportunity to barge in platforms. So we fabricated the platforms in China, delivered them by barge, and floated them in, and lowered them onto the existing pile caps. And that meant there was effectively no temporary work for the construction of these platforms on site. So we've got 40 metre by 20 metre working platforms installed in a morning and ready to operate immediately. And again, we're using flat top barges for storing the supporting equipment. So compressors, water tanks, generators, etc. are not stored on the platforms, so the platforms are designed just for the major plant, the cranes, the piling rigs, the elevator working platforms, etc. Precast shells, again, coming back to the off-site fabrication, minimizing work on site. So we're currently installing the precast shells on top of the board piles now. So again, the precast shells constructed in China, access platforms already on the top of them. We still have to do site works to prepare the board pile to lower the dolphin onto and ensure we have a watertight seal, but that's much reduced. And straight away, we have a safe, dry working platform for the construction of the in situ reinforcement. So again, it's a very efficient way of working, reducing temporary works on site and utilising the off-site manufacture. And then that just leads us to the boardwalk deck, the main boardwalk itself. So this is the opposite of the platform approach. So we have 63 deck units. Every single one is unique, okay? They range between 150 tons and 450 tons, and they're typically 25 metres long because that's the peer-to-peer span on the Island Eastern Corridor, and the width depends from 6 to 25 metres. So you'll see on the coming slides how we manufacture them. But in terms of the installation, we started in a stepwise manner. We started with a small panel, we started with the low panels and one panel per delivery. We then increased the complexity, moving on to more panels per delivery, up to 3 panels in one delivery, the high panels, and putting more architectural finishes and building services on the panels. So all of the modules are being built in Zhongshan in China and then barged across. This is the offsite production yard, and you can see a whole range of different shapes. These are all the different spans that we have that are under manufacture at different stages. So it's a steel beam composite deck, and then we're adding in the conduits, we're adding in the screeding, we're adding on the parapets and cladding, etc. So again, we still have works on site. We still have to do the installation of the support columns. You can see one of the lower columns on the left-hand side, some of the high columns on the right-hand side, because the boardwalk has to go over some existing piers. The first module with all the banners. That's delivered from the fabrication yard down to the barge using an SPMT. Again, onto the barge, delivered to Hong Kong, getting ready to install. And then not only are each of the panels unique, but each of the installation processes is unique. So the mooring is different for each panel, the tides are different for each panel, the weight of each panel, the geometry, all different. So we assess each location on its merits, and every single span has its own method statement for installation. So we understand the clearances we're working to, what time is the tide, what level do we need, and then we do the final securing. And again, we do construction animations for a whole range of temporary works to help people understand what we've got to build. And then we do the briefings. So it's generally the same team doing the installation, but the start time, the end time, the tides, the weights, as I said, all different. So we do dynamic risk assessments. Before every panel's installed, we get all of the workers, the supervision team, the RSS team, everybody stands around and goes through the same briefing. And this dynamic risk assessment approach is something that we apply across the project, not just for the deck installation, precast shells, extending the piling platforms. It's a really key part of works, and I know it's something that CIC are actively promoting as well. Dynamic risk assessment through construction to help reduce, to help alert the workers on the risks and help reduce incidents and accidents. So then we position it. We rely on the tide to lower down and also the axles on the SPMTs. And then we've moved on. So those early pictures were the early panels. Now we're putting the glass parapets in place, the screeding, the conduits. So here you can see a section in front of Kodak House. You can also see the different levels between the adjacent panels. So again, the geometry, everything's different, but through the fabrication yard in China, we're able to manage that process so that we have very efficient works on site. And that's just some pictures of the completed modules after installation. So thank you very much. I hope that was a useful talk. And now I'll pass over to Thomas, I think.
Thank you. Thank you, Philip. 再一次唔該 IEC Walkway 嘅代表。而家大家喺熒幕上面咧會見到我哋有一個 QR code 嘅，因為議會最近咧其實都進行緊一個吊運工作安全同埋實踐嘅問卷調查，咁業界嘅各持份者都可以去掃描熒幕上面嘅 QR code 去進行呢一個問卷嘅。 我哋一陣間嚟緊嘅時間就會交俾我哋建造業議會嘅主席何安勝教授工程師同大家一齊致閉幕詞嘅。我哋有請主席。
好各位2500位網上嘅建築人，大家下午好。咁首先好多謝阿 Ian 同埋阿 Philip 好精闢嘅解釋。咁睇翻我哋喺好快就1個月啦。喺過去嗰1個月呢，其實我哋都有死亡事故嘅。咁喺啟德嗰度，大家都知道啦，嗰個13米乘8米嘅竹棚呢，都跌咗落嚟呢，都引起2個嘅死亡事故。咁呢個係上次已經講過啦。但係喺大約1個月前呢，喺葵涌醫院呢，有位29歲嘅管理人員呢，都喺度個跣腳呢，都喺個竹棚嗰度跌咗落嚟呢，就喪生。咁除咗呢樣嘢之外呢，大家都睇到呢，喺過去嗰幾個禮拜喺洪水橋嘅地盤呢，有個4級嘅大火，咁燒咗呢43個小時嘅。咁喺一個秀茂坪嘅地盤，一個打樁機呢，你睇到一跌就跌咗落嚟呢，就壓到嗰啲機械。咁你睇到呢張圖呢，嗰個 housekeeping 呢係唔係太好嘅，同埋又係冇死亡地帶嘅。咁呢個就反映咗我哋而家嗰個安全嗰個文化係仲有好大嘅地方呢去改善。咁喺赤鱲角嘅地盤，呢個4月12號係啱啱上個星期嘅，有一位係釘板或者係紮鐵嘅管理人員，佢喺一個鐵嘅紮好鐵嘅地方喺嗰度穿過去。咁第一貪快啦，唔知點樣一轉身呢，成條鐵就插咗落去大腿嗰度。咁呢個又睇到，我哋個文化其實喺呢個月裏邊呢，我哋仍然呢係好脆弱嘅。咁我哋有咩辦法去解決呢樣嘢呢？我睇過呢20幾單嘅死亡事故，原來呢係有60%，60%嘅呢，大家係行單邊嘅。啱啱頭先我哋睇到嗰個 case 都係啦，喺葵涌醫院一個29歲嘅管理，唔係行孖邊，唔係大家互相合作、互相扶持，咁自己跌咗落嚟，我哋啲 4S 都影唔到係咩事發生。咁所以我真係要奉勸大家，由今日開始、聽日開始，真係我哋如果去行地盤，真係同一個 buddy 一齊行，大家互相幫助、互相扶持，一句問候，一句小心啲，就會救到我哋嘅生命。咁所以呢個喺大家睇到我哋呢個情況，呢個其實安全係文化係習慣。如果大家習慣咗呢個孖邊嗰個安全嘅係數，一定係可以加強嘅。安全係文化，係心態，係習慣。我哋睇下點樣將我哋嗰啲陋習解決咗佢。喺火燭方面，我諗食煙喺工地都好常見。我睇到好多工地，大家其實都有 designated 嘅 smoking area。咁但係啱啱喺嗰個43個鐘頭嘅火裏邊，可能係有啲火種留低咗，就啱啱喺食晏嘅時間冇人喺度嘅，咁一發不可收拾，43個鐘頭。咁我就諗有咩計仔咧？係咪可以擺啲 heat sensor 喺度咧？你日都記得中間度都係有發生過呢個大火嘅。咁之後咧，嗰個 contractor 都擺咗啲 sensors、heat sensors 喺嗰度，唔多錢嘅。咁大家睇到咧，其實前幾日都係咁嘅情況，有6條生命奪去咗， 同埋琴日又有一單火災啦。咁所以我奉勸大家呢，喺呢個咁緊張嘅時候呢，快啲喺我哋工作嘅地方買啲 heat sensors， 等我哋可以預先知道，用咗我哋嘅 4S system， 一有響警號，我哋即刻會喺我哋個 iPhone 會知道，我哋會即刻去救火，唔好等到去做咗1級、2級、3級、4級，係救都救唔到。咁呢個係用科技係可以解決。咁啊，仲有呢，我啱啱去同呢位17位呢位不一樣嘅工友去幫手去救火嘅。我大家傾咗落嚟，我哋喺工地裏邊一定要對呢啲咁嘅火災呢有呢個 preventive 嘅計劃。而家喺工地呢都冇個防煙罩嘅。其實喺防火方面，最緊要就係啲煙，煙一吸咗呢，即刻會暈低嘅。尤其是喺地下、喺地庫、喺卡帕。咁所以我哋大家真係將呢個防煙罩擺翻喺啲地庫嘅工作裏邊，擺翻喺我哋寫字樓嗰度，同埋做一大輪我哋嘅訓練計劃，試下點樣走火。好多人已經忘記咗我哋呢個基本嘅程序，咁所以希望大家知恥近乎勇，知道有呢個情況出現，同埋照睇呢個風險都唔細嘅。咁頭先大家都好多謝阿 Ian 同阿 Philip。我點解今日揀呢個臨時工程管理呢？就因為喺過去嗰27單嘅死亡事故，其實有70%係因為臨時工程管理計劃係冇嘅，所以而產生嘅。咁所以我特別請呢兩位專家嚟話俾大家聽。喺呢兩位專家講得好清晰，唔好等我哋到施工嗰時，只係諗我哋嘅臨時工程。喺設計嗰度呢，我哋都要利用臨時工程師去設計好，將嗰個風險喺建築嗰度、喺設計度已經剔除咗啦。頭先大家見到啊 Philip， 你睇到有好多已經喺預製咗，都唔使喺工地有人員去做嘅。呢個就係臨時工程管理啦。咁呢個好清晰，一定要喺個設計嗰度呢已經做好，剔除晒嗰個風險，同埋喺施工嗰度呢，利用我哋嘅電腦化，利用呢個數碼孿生嘅技術，做好晒個人企邊度，架機點樣行法，做咗10次8次，萬無一失啦，至去開工。咁呢個就係我哋點解我哋有臨時工程管理計劃，同我今日點解仲辛辛苦苦都要講俾大家聽。因為呢個有70% 嘅死亡事故係由於沒有臨時工程管理計劃造成嘅。喺過去嗰20幾單嘅死亡事故，有42% 嘅死亡嘅人呢係60歲以上嘅，42%。咁所以我就喺度呢再呼籲大家，真係喺我哋嘅工地呢，一定要有呢個 N 帽、P 帽同埋 C 帽。C 帽就係60歲以上嘅。我哋係喺我哋嗰個 4S 個 system 呢，可以睇到我哋60歲以上嘅工友喺邊度工作。我哋可以派我哋啲有經驗嘅兄弟姊妹呢，去俾特別嘅支持佢哋。咁 P 帽係咩呢？深入去地盤，我哋係要又揾個老手睇住佢3個月、6個月，等佢熟習咗啦，然後呢至放手。N 帽 係新去地盤嘅，雖然你係好有經驗，但你佢個工地唔清晰咧，我哋都揾位老手咧，去同樣跟你3個月、6個月。點解我哋講呢樣嘢咧？頭先我講緊葵涌嗰位29歲嘅兄弟，佢入咗地盤咧，差唔多3個月嘅啫。即係我深信，如果我哋喺之前有孖咇，又有呢個咁嘅 N 模 P 模，有人提攜住佢嘅話，係咪真係諗到唔會跣腳咧？咁呢個就係希望我哋點解我喺度再 reinforce， 我哋一定唔好掉以輕心，一定要繼續堅持有 P 模、有 N 模、有 C 模。我睇過咗過去嗰5年，因為棚而有死亡事故嘅，呢5年有15單，用竹棚嘅14單。係得1單係鐵棚嘅，就跌咗落嚟。最近我聽阿吳浩康講，佢而家係做緊鐵棚嘅。佢話：佢做嗰個地盤咧，如果你冇帶呢個 double harness 雙尾繩嘅咧，唔俾你上鐵棚嘅。咁咪解決咗咯，連鐵棚你嗰單都冇埋。咁所以我喺度呼籲大家，如果我哋可以用鐵棚嘅，麻煩大家用鐵棚，跟住用晒雙尾繩至上棚，咁就真係呢5年咧都可以救到15條人命。所以我喺度講，係咪竹棚係死亡之源咧？係咪真係要我哋滴起心肝去做？我唔係話要全部取締竹棚，如果鐵棚做唔到嘅，我哋一定要用竹棚，因為竹棚都有佢好處。但最先我哋考慮鐵棚先。咁呢個頭先我嗰個解釋，我諗相當清楚。我最近去過我哋嗰個中央宿舍探一探我哋啲外地嘅工友，有4位咧就啱啱喺呢個國內嚟，佢哋係做搭棚嘅。佢同我閒談嘅時候，佢話：喂，主席，點解你哋咁落後啊？我哋國內都冇竹棚噶咯。我同埋咧。我用呢個機械人去搭鐵棚嘅，同佢話俾我聽，而家出嗰啲竹咧，同以前嗰個品質係唔同，嗰個力量係唔同嘅。所以真係再激發起我，真係要諗一諗，點樣真係將我哋嗰個即係鐵棚，等大家做好佢。我希望喺呼籲大家喺呢方面咧去睇一睇，因為大家都知道。咁容易有死亡事故嘅，你停3個月、停6個月都不得了嗰個時間，唔好為少少嘅錢咧，去破壞咗呢啲家庭嘅生命。咁喺度我就再想講咧，喺呢20幾單嘅工程裏面咧，都沒有做到動態風險評估嘅。沒有做態風險評估嘅。今日大家如果乜嘢都聽唔到，唔緊要，最緊要你晏啲開工，未開工之前，麻煩大家一定要做咗個動態風險評估。For Ian and Philip, before you commence work, please exercise the dynamic risk assessment first. Don't commence any work until you have done the dynamic risk assessment. 大家睇到呢27單嘅死亡事故，如果大家做咗呢個動態風險評估，全部都可以救咗條命。要知道火種喺邊度，有個煙頭嘅。未收工，12點未收工之前，巡一輪先，去葵涌嗰位行晒孖咇，睇晒個竹棚有啲咩風險，然後至上棚嘅，冇事。嗰位工友睇到啲鐵嗰啲 鐵頭都未有我哋呢個黃保護嘅 cap 咗嘅，我唔好行埋去。呢啲就係動態風險評估。呢3單大家做咗就唔會行埋去救咗啲生命啦。所以我重申，唔好貪快，千祈唔好貪快，一定做咗3分鐘、5分鐘動態風險評估先，呢個絕對重要。跟住要做嘅就係，又係唔好開工字，除咗做咗呢個 pre-work briefing， 去到當地管理人員講晒啲風險俾我聽，講晒俾我聽，一步一步，一行跟一行，一行保護一行，講晒，唔使好耐時間嘅啫，然後先開工，明白咗至開工。呢個係救命3寶嘅第2寶。第3寶，如果同個施工計劃書係不同嘅，即刻停。頭先大家睇到阿 Philip 講咗個施工計劃書 ，the method statement step by step very clear. If the actual site situation is different to the method statement, stop. 舊年都有一間死亡事故。喺房屋處，喺16樓出事，15層都係6日冇事，即係去到第16樓有改變，但係唔發覺，唔識停，所以一有覺得同嗰個施工計劃書有改變，同下面嗰層唔同嘅，醒啦，停睇睇先。所以呢個就係第3招，救命3寶。最近我去見過好多工友，我問佢點解我哋仲有咁多死亡事故？你聽唔到我哋嘅呼籲嘅咩？佢話我聽到啊。我同佢分析點解嗰13米同8米嘅竹棚都會咁飛落嚟咧？梗係有人 cut 咗啲嘢啦，係嘛？咪冇理由飛得出嚟嘅。咁我最尾再問佢，危險嘅喎，你仲會唔會再 cut 咧？好不幸，佢話俾我，佢都會仲 cut 嘅。咁我就大鑊啦。仲有個水喉嘅兄弟話俾我聽，如果一驗樓、一驗消防咧，我就趕工㗎啦，就出事㗎啦。我呢個故事教訓咗我哋咩咧？我哋一定要管嘅，一定要有管理嘅。或者同大家分享都得，呢20幾單嘅死亡事故，啲管理人員我哋都唔知喺邊度，次次都揾唔到。咁我同啲工友傾。佢其實聽邊個人嘅説話咧？佢就係聽佢個頭頭講。佢同埋講，而家唔知係咪我哋嗰啲基本功冇晒，真係識睇地盤嘅，睇工程一行交一行嘅，或者我哋啲文件係咪太多咧？佢話俾我聽，我哋而家啲管工咧係影相同埋數人數嘅啫。咁同埋，你搞掂佢，寫一層，交到貨就得㗎啦。咁所以嗰位工友佢就聽佢個管工講，而嗰位管工就聽分判商嘅揸 fit 人，分判商嘅揸 fit 人就聽我哋大判嘅分座管工或者 area foreman 區域嘅管工。咁所以個故事教訓我哋就係唔該我哋將我哋呢啲管工全部訓練得好佢，要有監督之下才開工。No supervision, no work。唔夠 supervision 都要 no work。如果唔係就出事。所以呢27單嘅死亡事故就因為咁樣發生。所以呢度衷心咁呼籲大家， 將我哋呢個管理做好。我哋喺議會已經喺我哋泥水、釘板、紮鐵、砌磚，都將呢個一行保護一行，因為斬咗嗰啲竹篾就等於謀殺。我哋要將呢個觀念去教翻我哋嗰啲泥水工友、泥水工匠、做瓦仔工匠，要一定要將呢個正確嘅理論灌輸俾佢哋。議會會責無旁貸咁做，但我想大家作為建築嘅僱主，作為分包商嘅僱主，作為我哋大家喺網上呢2500位嘅管理，知恥近乎勇。依家就要 make sure 冇監督嘅唔好開工。你做完個動態風險評估係有足夠人手啦，係足夠嘅一步行一步，然後至開工。我知道唔容易做，但係千里之行，始於足下。最後我想講呢，就喺嚟緊呢，就係5月、6月、7月、8月呢，喺普遍嚟講呢，係50%嘅死亡事故呢，通常呢都喺呢幾個月發生嘅50%。咁嚟緊呢，酷熱天氣呢係會只有越嚟越熱嘅啫。我都可能喺上幾次都講咗啦，喺10年、20年前呢，酷熱天氣係得13日，舊年呢係53天。我估計啊，今年可能會仲熱啲添。所以希望大家呢喺呢個時間呢開始呢，將我哋嘅酷熱天氣嗰個程序俾揾多啲水啊，做多啲遮陰嘅地方啊，做多啲 modular 嘅遮陰地方，開始呢去執行呢個酷熱天氣下嘅施工如何做好啦。希望大家真係知恥近乎勇，去改變我哋嗰個文化，改變我哋嘅壞習慣，為我哋生命第一，向危險說不，努力。多謝大家。
唔該晒主席。而今日嘅研討會亦都差唔多，我哋下個月嘅 Water Talk 再見，多謝。